So when you are dividing decimals, right, we're going to kind of think here in this video about how to interpret a remainder, right? As you are dividing and you're like, oh, I think I'm done. I have a remainder, right? We're going to kind of move into what to do when you do have a remainder when you're working with decimals. So when you are working with decimals and you're dividing, you will end up not having a remainder. So what that means is as you're dividing, you don't want there to be this sort of, R2, if you will, right? This remainder two, or if you know how to turn it into a fraction of a remainder of two out of your divisor of 5, right? We don't want any of that. We want to stick to the land of decimals. And we want to know, it's a really helpful tool to be able to know what to do here because you'll be able to find out if your answer, right, if your quotient either ends, right, so it's what we call a terminating decimal, or if it repeats, right, um, or neither, right? So you can have a non-repeating decimal, but you can get some really good information about what type of decimal you have. So if we have this problem here, right, and we have 12 divided by 5, first things first, it would be set up like this: 12 divided by 5. Okay, so you have your dividend first divided by your divisor. So 12 divided by 5. And we'll say, well, how many times does 5 fit into 1? 0 times. How many times does 5 fit into 12? 2 times, which is 10, right? When we subtract, then we say, ooh, well, we can't have this remainder, right? We can't have a remainder of 2. So what we're going to do is we're going to say, well, 12, is 12 the same value as 12.0 or 12 and 0 tenths? Well, yeah, it's the same. So we can add a decimal point with a 0 here because it's the same value, right? It now just has a different look. So once we do that, we add this decimal point with this 0, we now have a digit to bring down, right? So we can now say, oh, well, does 5 fit into 20? And we can say, yeah, it does. So when you do that, if we scroll, you can say, all right, well, I'm going to bring up my decimal point, right? So that I can just pretend kind of like it's not there. You want to make sure it goes directly above, right, where it started. And then you'll say, how many times does 5 fit into 20? If it's 4 whole times, exactly. So 5 times 4 is 20. There's no remainder left over. So we've done it. We're done. So 12 divided by 5 is 2 and 4 tenths, or 2.4. So if we do another example, we could say that 13.1 divided by 3. Okay, well, let's figure it out. So we're going to start by bringing our decimal point directly up from where it started, right, up into our quotient zone. How many times does 3 fit into 1? Well, 0 times, but how many times does it fit into 13 if it's 4 times, which is 12? When we subtract, we get 11. How many times? Sorry, we get 1. When we drop it down, right, we get 11 because we have a digit to bring down. How many times does 3 fit into 11? Well, it fits 3 times, right, which 3 times 3 is 9. When we subtract, we have 2 left over, right, but we can't have a remainder. So what we're going to do is we're going to end up adding that 0, right? Oops, so this is 4.3. Okay, so we're going to add that 0, and then we now have a digit that we can bring down, and we say, how many times does 3 fit into 20? Ah, well, that fits. So we can say, I know that it fits 6 times, which is 18, right? 3 times 6 is 18, and we have 2 left over. Ooh, so I'm going to go ahead and add another 0, right? So I add a 0, I bring it down. Here we go. We have a 20 again. So now we say, well, it fits 6 times again. And when we subtract, we have 2 again. So we're finding that there's going to kind of be this pattern, right? So we could add another 0, bring it down, and that's going to go forever. So what we determined here is that this pattern means that there is a repeating decimal. So you can put a little hat over the 6 or the 6's because it's going to